Hi, everybody. Welcome to session 3 of our Introduction to Data Visualization in Observable Plot course. This is the third session, so as a reminder, if you are new to plot or haven't seen sessions 1 and 2, go back to our playlist for these videos where you can rewatch sessions 1 and 2, which cover some fundamental skills for getting started in observable plot. Because today we're going to be adding a few more complex methods to view our data, including new transforms, faceting, and even making a map. So we have a lot to look forward to today. So I will go ahead and jump right in. So let me get my slides to advance. All right. As a reminder, we have a whole team here ready to help. I'm Allison. I'm a data scientist advocate at Observable. I'm leading the course, but also here to answer questions, both in the stream chat here, but also we have a Observable community Slack channel for this course that you can join. The Introduction to Observable Plot channel is where you can ask questions there or ask plot questions in just the general help channel on our community Slack. We also here have Robert, a data visualization developer at Observable. Robert's behind the scenes ready to respond to questions. And we also have Henna, our social media manager at Observable, who will be sharing links and following up and sending out follow-up emails to keep us all on track for the course. So we're all here to help. And as a reminder, a few logistics. Again, you can post your questions here in the chat or in the community Slack channel for the course. You do need an Observable account if you want to follow along with the code along activities and save your work, which we highly recommend. So if you haven't done that, you can make a free Observable account to get started. We recommend having 2 screens side by side if you're going to follow along so that you can watch what I'm doing and code along on a different screen or to the side screen. In the follow along notebook that we're going to share, which is where you can do your work in your own copy, there are show me buttons throughout that will show you the code that I'm going to be creating so that if you get stuck, you can click on that show me button and it will reveal the code that I'm adding so that nobody hopefully gets left behind. And finally, all keys, slides, and recordings will continue to be available after this class is over. So you can always go back and rewatch any parts that you may have missed and find all of the notebooks, both the keys and the follow along versions if you want to follow along later. So I think that's it for the getting ready. Let's just jump right in. In sessions 1 and 2, we covered the grammar of graphics and how that aligns with how we build data visualizations in Observable Plot. We talked about marks, which are geometric shapes that we use to represent our data. We talked about scales. So how do our values from our data map onto different scales, whether that's axis scales or color scales, for example. And we also talked about transforms, which can help us get our data into the shape that we want to visualize it right within plot so that we don't have to do that outside of plot first. And those can be mathematical transforms like converting something to a log scale, or they could be binning, grouping, or normalizing things like we did last week using different reducers, like finding the count of observations within different bins of a quantitative variable value. So this is what we've covered so far to get up and running. And today is going to be a fun one. So today we are going to start with a little warm up that's called a warm up, but we're actually going to learn something new. And then we are going to continue adding versatility on this strong foundation that we've built in sessions 1 and 2. We're going to facet, we're going to add annotation, we're going to add new transforms, we're going to create a map, which feels so fun in Observable Plot. And then at the end of the day, if there's time, we're also going to do a quick teaser for adding interactivity to your visualizations using observable inputs. So let's go ahead and jump right in. So the first thing that we're going to do during this warm up is we're going to learn how we can create facets. So faceting splits up data by an ordinal or categorical value, like for different species or for different groups of something, and creates a plot for each of those subsets in its own panel. And faceting usually is enabled by declaring the horizontal facet channel, fx. So that's where you can say, like, for which variable do I want to identify different groups and then split them up into different horizontal panels, or a vertical facet channel, fy, where we're saying, for this variable, I want you to identify different discrete groups, and then those groups will populate the different vertical panels, or those vertical facets. Or you could use both if you want to make a grid of faceted small multiples. So for example, and I just wanted to highlight one example, we're going to do something different, but just to show you how this works, here's some code showing what this can look like using the built-in penguins data. Again, just to reiterate, we initialize the plot with plot.plot. Then we say what the marks are. So what's the geometric shape we're using to represent the data. We make a histogram by creating rectangles where there's binning created along the body mass variable of the penguins data, and the y value, the height of that rectangle, is the count within each of those bins. That's how we create a histogram. We learned about those bin transforms last week. But then we can see that there's one additional piece of information added that we haven't seen yet, which is this fy species. And what this is doing is saying, hey, I actually want you to look in this species property and identify the different unique groups that exist there, or unique categories. And then I want each of those categories to exist in its own panel of this visualization. And that's why here we see that these three penguin species, Adelie, Chinstrap, and Gentoo, they don't show up as overlapping or stacked histograms. They show up in their own individual facet, and that's all done with this fy species option, which is really nice. So that's what we're going to practice today, along with our warm-up activities. So let's go ahead and get rolling. So in the chat, you'll see that the link for the follow along notebook for today's session is shared. So I'm going to hop over to that. And once you navigate to that link, you should see a notebook that looks like this. And again, if you're unfamiliar with observable notebooks, you can go back to session 1 or to some of our learning resources on Observable to learn how to get started with notebooks. So here we can see we're in the session 3 follow along notebook, and this has pre-populated information, placeholders, and indicators where we're doing activities. And it also has all of the data that we're going to be using preloaded, because this is a course about making visualizations with plot. We have other courses that cover how to attach files and read data into Observable, and a bunch of other resources in our documentation. So the first thing that we want to do is we want to fork this, which is to make our own copy in our own account. So the way that you're going to do that, if you have an Observable account, you'll see this fork button up top. Go ahead and click that. So I am going to click that. And then you can choose the workspace this is going to. You may only have one. And then click the fork button. You can also set the visibility here, but if yours is set to only you, that's totally fine. And click fork here. And what this is doing is making my own copy. You should see now that you have your information at the top of the notebook with your avatar and name, and it will indicate that this is a fork. Now that this is in your own copy, you can go ahead and start working, and all your changes are going to be saved. So for the first warm-up activity, we're using data from World Bank Open Data, which contains information about a bunch of different metrics, in this case, CO2 emissions, GDP, and life expectancy for different countries over different years. And we're going to do some exploration, but what I've already done is I've already created a little kind of unhelpful chart below to get us started. So we're not going to start from scratch here. We're going to start from this already created chart. And what we're going to do are these things. We're going to add channels that update the radius and fill color based on life expectancy. Remember, channels are options where the value of that option is time. If it's based on a constant, those are called constants. We're going to change the opacity of some of our points. We're going to change the color scheme. We're going to convert the X and Y scales to log. We're going to update axis labels, and we are going to facet by income group for this case. So that's what we're going to do for our warm-up. So we'll jump right in. So this original or this kind of base plot that I've already created uses methods that we've already practiced in this course. So I'm not going to review all of this, but we can see that we have a dot mark created using the World Bank data. Notice here that I have a little filter built into this mark, which is nice. So this is only showing data for 2010. On the x-axis, we have GDP, and on the y-axis, we have CO2 emissions. We have some other information about these different channels, but actually these aren't changing anything because these channels don't exist yet in our code. So let's go ahead and do a couple of these things. The first thing that I'm going to do is I'm going to update the fill and the radius of my dots to be based on life expectancy. So these are additional options within my dot mark. So I'm going to say I want the fill to be based on life expectancy. And now when I run this, I can see that I have this new color scheme. And I similarly am going to have the radius change to be a channel based on that life expectancy value. And we can see there's a lot of overlapping points. We also see that there is a huge range of values on both of these scales, right? Just looking at GDP, you can see that there's orders of magnitudes of difference between values on this scale. And for that reason, a lot of the values at lower values of GDP are really compressed and overlapping. So one thing that can be helpful if that's the case, if your data covers, like huge orders of magnitudes and you want to kind of compress the scale that things are visualized on, then what we can do is we can go ahead and update the scale to be a log. But we saw last week, you can also use like a square root transform or a power transform or a transform that you create. But I'm going to go ahead, and this is outside of my marks. Now I'm just updating these scale information. I'm going to say X, and then for this X scale, instead of the default linear scale, which this chart is usually using by default, I'm going to say type log. And this changes the x-axis scale to a log scale. And similarly, because we also see the same issue happening in the y direction, similarly, I'm going to change the y scale to log. So I'm going to say y type log. And now I can see that both my X and Y axis scales are on a log scale. So it's really quick to change the scale to, in this case, a log-log plot of GDP versus CO2. We wanted to change a couple of other things too. So we can also update if we have a lot of things overlapping. We can, for example, change the opacity of a mark. So this is within the mark. So for plot dot, I'm going to change the opacity, for example, to 0.5. Now I can see that all of my observations are slightly translucent. When you use opacity, 1 is completely opaque, 0 is completely transparent, and anything between is on the spectrum of translucency. So we've made already a lot of changes that have changed the look and feel, but the last two that we're going to do are we're going to update the color scheme, and we are then going to add facets. So here, my color scheme is going to happen down here in this color legend true line, where I'm updating information about that color scale. So within color, separated by a comma from that legend true option, I'm going to say scheme. And then you can see as soon as I type in my double quotes, I have a bunch of built-in color schemes that I could pull from by name. You can also create your own custom color scheme, which we've seen in a previous session. But here, for example, maybe I'm going to choose plasma. Plasma. And now I can see that the colors in that chart immediately above have changed. I could change this to blues and purples. And now I see that that's using the built-in blues and purples scheme. So from these built-in color schemes, you can really quickly change the scheme of your continuous or categorical color scheme. I recommend looking at the documentation for plot for seeing the different available color schemes, and make sure that you're picking a color scheme that aligns with the type of data that you have. For example, you might not want to use a continuous color gradient to represent distinct categories of data. So we want to pick a color scheme that matches the type of data that we're using. All right. So we have already changed a bunch about this chart in relatively few lines of code. The last thing that we're going to do is facet this. So instead of having a whole separate line to do this, all that we need to do is set either FY or FX or both within the mark that we want to be faceted. So in this case, my dots are what I want to be faceted, and I want those to be faceted by income group. And that means instead of having a single chart like we see here that has the location on our coordinate system represented for GDP and CO2 for all of the countries in this data set together, instead what I want is to have a separate panel for each of the income groups. And I can do that here. I'll use FY by saying FY and then adding the property, in this case, income underscore group, that I want to facet that by. And you can see here that now I do see each of these different income groups has their own panel that it exists in. Now, one thing that can be really helpful is small multiples. So faceted data visualizations are really valuable because it can allow you to focus on subsets of the data just in one panel. But something that can happen is that you can also lose some context in terms of how that subset relates to the overall population or the overall set of data that you have, because you're only viewing a subset. So I did want to show one more cool thing, because I think observable plot makes this like very, very easy. And this is a thing that in other tools can be very challenging, which is how can I, within each of those panels, show both like the overall data that I have, but then show highlighted the subset within each panel on top of that to give it some content. So here what I'm going to do is I'm going to go ahead and I'm going to create a new mark that contains all of my data, but that only sets the color to gray for those. And I'm going to put that before this dot mark that I'm using here. So I'm going to go ahead and copy this entire dot mark. So make sure that you're getting the whole dot mark all the way down to that final parentheses. So here, oh, good question. Mackenzie, I see a question from Mackenzie that says, how do we reverse the color scales? I think within the scale, you can just add a reverse true. Yeah, and then that will reverse the color scale. All right. Oh, and I see another question. Does plot have a scales equals free Y type of feature? Good question, Sam. I'll need to get back to you with an answer for that. But just to describe for the group what that question is asking is, by default, all of the panels will have the same X and Y axis limits or axis scale, regardless of the actual values within that subset. And in other tools, you'll see an option for setting the scales to free so that the scales are adjusted based on the content within a specific panel. So I will follow up in the Slack channel for this course with an answer to that, because I'm not sure off the top of my head what the method is for that. Yeah, good question. Okay. So getting back to putting this in the context of like all of the data, I'm going to copy this entire dot mark all the way down to its final parentheses that matches up with that first parentheses after plot dot. I'm going to copy it and I'm going to paste it right above my my first dot mark. So now I have two dot marks, and at this point they're totally redundant. Like this plot's the same thing one on top of each other, which would work, but like you're just plotting the same thing twice. And instead what I'm going to do is I'm going to remove the faceting for the first one, and instead of having the fill be based on life expectancy, I'm going to set this to like a light gray, because I want this to contain all of my data. So all of the data, and I want this to be light gray. And then on top of that, within my facets that happen for the next mark, those are going to be these blue to purple in my case. You might be using a color scheme on top of those gray marks. And now if I run this, what's really nice is that you can see, although I'm going to update my opacity for my faceted marks. But what you can see that this does is that this really quickly puts all of your data points from the entire data set for GDP versus CO2 in the background in gray. And then it has, for each subset, those are chosen in your colors, using your color scheme in each of the faceted panels. So this can be a really nice way to put your data in context of the whole when you're breaking up things by faceting, because sometimes by faceting things into small multiples, you might also be worried about losing context about how does this relate to the whole. And this gives you a really quick way to get back to showing both the highlighted thing within each panel, but also in the context of the larger data set, which I think is really nice and especially great in plot. So how do we, so I see a question here. How can we rearrange the facets? Good question. So you can rearrange the facets using a different domain. So if you wanted to do that, and I can show you that really quickly, if you wanted to rearrange the facets, because like in this case, the order is not correct, right? I'm going to update my margin so you can see all of these. So if I do margin right, maybe 100 will let us see all of those. So you can see like upper middle income is at the bottom, NA is second, lower middle income, low income, and then high income. So these are in reverse alphabetical order. You can set a new domain to actually have full control over the order of those things. And that would be in your FY scale. So here I can add within outside of my marks, but within my scale options, FY, and then I could say like domain, and then give it the new array with the order that you want. So this could be like NA and then low income and then lower middle income. You need to make sure that these match the actual levels, otherwise this will misalign. And then upper middle income and then high income. And once I've set that new domain, then this will show up in the order that I want it to be in my chart. So the domain is where we say what's going in. And then just to reiterate a couple of things we covered in the last courses, the range is where we say what comes out. Yeah, great question. Okay, and if you wanted to, because you'll see now if I scroll up, now I can see that these go from NA at the top to low income to lower middle income to upper middle income to high income. If we wanted to reverse that, a really cool thing about working in plot is that like The options you have start becoming predictable because they're very transferable across different scales. So just like we could reverse the color scale, we can also reverse these facet labels, these facet groups. So I could say here, still within my f of y outside of the domain, I could say reverse true. And then this is instead going to go from NA on the bottom to high income on the top. So then I could see that I now have a reversed scale, which is pretty cool. So I think it makes faceting and showing things in context and reordering things in the exact order that we want them really, really nice. Great questions, everybody. Okay. So there's our warm up where we also warm up slash let's learn a bunch of new things. Great. Okay. So now I'm gonna hop back to my slides because we are gonna jump into some more customization. The first thing we're gonna do is learn a couple more transforms. So in our session 2, we learned about bin transforms and group transforms and normalization. Today, we're going to learn about a window transform and a select transform, which can be really powerful for like reducing noise to show trends within noisy data because you're calculating some summary statistic within a window across your entire data set. Oftentimes, that's time series data. And then we're also going to use a select transform to help us select just specific observations from our data where we want something to happen, like where we want an annotation to show up. So in a window transform computes a moving window and derives summary statistics from the current window, like to compute rolling averages, rolling minimums, or rolling maximums. And here's the example from the observable plot documentation. This is time series data for temperature, but this is showing the original data, which is shown here in gray, but this is also showing rolling averages for average high temperatures and average low temperatures over a specified window size. So this is what we're going to practice in our next example, but we also want to be able to label series. That's going to be another part of our next example. And to do that, we're going to use a select transform. So one thing that a couple people commented on in, I think, session 1 was like, when I try to add text, the text shows up at every single value in my data set, which is sometimes what you want, but sometimes what you want is just to add a label at one location. Like, I want to add the name of a series just at the last position that series shows up in. And the select transform allows us to do that. So the select transform filters a marks index to show only a subset of the data. It's a specialized filter transform that pulls a single value or sample subset out of each series so that we can place something just at the value of one observation instead of across all observations. So it's a really nice way to have like text placed at one location, like a maximum value or at the final value, without having to kind of do custom artisanal coding to create that. So it's a built-in transform we can add. So these are the two that we're going to use in our next example. So let's go ahead and start adding some complexity in our transforms by doing a window and a select transform. Okay, so hopping back into my notebook. As a reminder, if you got lost or missed anything, you can look back at the code key, but you can also click on these little show me buttons. Those will reveal the code and those will reveal the outcome of that code. So you can follow along by looking at the show me options, at the show me buttons too. Okay. So for activity 2, we're using a different data set. Again, the data here I have already attached and wrangled and imported. That's why you can see if you look at the little paper clip in the right margin of your forked document, you'll see that there are 5 files attached. Those are the files that we're using. Those already exist for us, and the data set that we're using for activity 2 is closing prices for 3 companies, Apple, Google, or Alphabet, and Tesla. And there's already, again, a pre-built line chart that is built using the skills that we developed in sessions 1 and 2. But here, we want to make a couple of changes to these. The first thing that we want to do, because we can see that there's quite a bit of noise, this is daily data. So we see these kind of high resolution fluctuations. The first thing that we're going to do is to add a line mark with a window transform that shows kind of a noise reduced version of the time series. So here we're going to add a window transform that allows us to see kind of a broader trend without some of this noise. We also are going to add annotation with plot tip, and we're going to add text labels directly to the lines using a select last transform, which is going to let us add a label only at the final value of each of these series to let us know what the series is. Which that might not be necessary here because we have the legend, but sometimes, especially with like legends with a whole bunch of categories, sometimes directly labeling lines is clearer for audiences and makes them have to do less back and forth from like legend to series to match things up. So direct labeling can be really useful. We're going to learn how we can use the select last transform to help us do it. And we can finally customize the categorical color scheme by updating the domain and range of our color scale. So this is what we're doing for activity 2. So let's go ahead and hop right in. So we have this already existing line chart, but what I want to do is atop each of these lines, I want to add a window transform to show kind of a smoothed version of what these trends look like for each of these different companies. So instead of writing things out from scratch, what I'm going to do is say, well, I still want that background line to show up, but I actually want the smooth version to appear over the top of it. So we're going to add a new line mark. But that new line mark is still going to be using the same, variables for X and Y. So I'm going to go ahead and just copy that first mark that's already existing. And then I'm going to make sure you have a comma between marks. And then I'm going to paste that immediately below. And again, if I run this, this works. This is just completely redundant. This is just one mark immediately on top of the other mark, so we don't see a difference. But for that second mark, the ones that are showing on top, remember these are showing up layer by layer, I don't actually want to show the original locations of date, that's the date, and then close is the closing value in dollars. I don't want to show that original value. I want to show a calculated rolling average at each of those dates based on a window size that I specify. So for each date, am I showing the mean of a window of 50 days, where the default here is that your value is the center. And so that would be like 25 before and 25 after, calculate the mean of all of those and then plot that for that date. Or is the window size 3 days, for example? And the larger the window gets, the more smoothing that you're seeing over time in this with this window transform. So to make this a window transform, what I'm going to do is around these options, I'm going to start by saying like, actually for those options, I'm going to use the plot window Y transform. So that's around all of those options. And then just make sure you also add that additional parentheses at the end to make sure that everything is still lined up. But this is all that I've done so far, is I have only said there is going to be a window transform that's applied to the data that we're currently showing. So that's the first thing. But the other thing that window Y needs to know, because you'll see that it says, if I try to run this, it says invalid K, not a number. If you're using a window transform, The only option that it actually needs to know that doesn't have a default value is what is the window size over which you're calculating some summary value to plot. So the way that we're going to do that is we are going to have, just like we did for reducers when we were doing the transforms with bin and group, we're going to start right after window Y with curly braces. And this is where we say what the options are that are specific to that moving window. So here, if I say K is 30, then we could think of that as like giving me like the monthly average around the current date. And then when I run this, then I can see that this looks like a mess because we still have some work to do. But you can see that we do see not just that raw noisy data, but you can, it's hard to see because it's in the same color and opacity. You can see for each of these series, there's also a slightly smoother line that's been added on top of it. That is that rolling average calculated at each date over 30 days instead of just showing the value at that single date. So how might we make this a little bit more readable? Well, one thing that we might do is if we want the rolling average to be what people focus on, is we could increase or decrease the opacity of the first line that shows the raw data. So that's what I'm going to do. I'm going to add this opacity and then I'm going to make this 0.3 so that it maintains the color scheme for each of these series, but so that now we can really distinguish between that rolling average and between the original data. And you can go ahead and play around with that window size. So yeah, I could change this to, 90. And this would give me over 90-day spans around each date, 45 days before, 45 days after. What is the mean of all of those values? Because the default here is that it's a centered rolling average and the default reducer is the mean. Can we change that? Absolutely. So for example, if I wanted this to be a leading or trailing rolling average, I could say like, I want the anchor to be start. And then this would, first, thought this was start or last. Okay, maybe I'm getting the terms wrong that I need to make this. But I spelled anchor wrong. That was the problem. So if I use anchor start, then I can see that this is a, leading or trailing. And if I used anchor end, then I can see that this switches to the other side. So this uses values after, the other uses values before. But the default is that it's middle, that this is centered on the current date. And you can also change the reducer. Like if I wanted, instead of plotting the mean for all values within that window, if I wanted to plot the maximum, I can change the reducer. So I can change from mean to, for example, reduce max. And then I'll see for each of these dates, what is for a window of that size, the maximum value that was recorded within that window. So this makes it so nice to be able to calculate and customize rolling averages to determine how it's calculated, whether it's a middle or leading or trailing window that you're calculating. So it gives you a lot of different options really quickly to be able to create something like this. I'm going to convert this back to using a mean because I think that's the most standard, and I'm going to convert this back to 30 days. Okay, the next thing that I want to do, and I actually think I am going to, we're going to skip annotation with a tooltip, so we'll move that to session 4. But I do want to show how you can add labels for each of these lines directly using the select last transform. So here what I'm going to do, the goal of this, just to make this clear, is that I want to add the label for each of these companies, like Tesla, Google, or Apple. I want to add that right to the end of each series so that a person, especially if you had a bunch of different series, so that they could have that direct label there. So here, what I'm going to do is I'm going to add some text. So I'm using still within my marks, but make sure that you are after that second line Y. I'm going to add a plot text mark. And I'm going to add from the stocks data. So that's my first argument is I'm getting information from stocks. And first I want to see what happens if we just say like, let's give it the X and Y values and then what text to add. So let's see what happens. It's going to be a nightmare, but I think this will reinforce why these select transforms are really valuable. So I'm going to say for my options, I'm going to say X is date. That's the date property in my data set stocks. I'm going to say Y is close. That's the property name that contains all of my closing values. And the text that I want to add for each of these, I want to be pulled from the symbol, which is whether it's Apple, Tesla, or Google. Now, if I just run this code using this text mark as is, then you can see what happens is that this will do exactly what I'm asking it to do. It's saying for each date and each closing value, I want you to add text that is based on the value of that symbol property. And that's like Tesla and Apple and Google. But I think we can all agree that this is maybe not the most useful way to let people know what series they're looking at. I could also here update the fill color of this. So I could update the fill color to also change based on the symbol. Now we see that we have all of this text. But what we want to do is we only want to have each of these show up one time at the last value. And that's where that select transform is really, really helpful. So like we did previously, we are going to wrap our options for plot text in a plot select. And look how many options show up here when I do this. First, last, max, min, Y, win X, etc. So I'm going to use the plot select last transform, making sure that I don't forget my final parentheses. And just running that, now that I've wrapped it in that plot select last transform, I can see that now instead of having that text show up at every single value, it's only showing up at the final value in my data, which is really cool. You could also add transforms within this, but this gives you an idea for these series, how you could use select last to just have it show up once. Now, I think like a reasonable question is like, well, that's not great. It's centered over the last value. I might want it like dodged slightly to the right. And we can absolutely do that. We can update the text options. For example, if I use DX, that dodges to in the X direction. And I'll change this by 10. And this will move those over a little bit. And then I would want to change the margins of my chart to make sure that this isn't getting cut off. But you could similarly update the font size and the weight and the style. So there's a whole bunch of options for updating text marks that you can use that also work within this select transform. So in this example, we have continued customizing by not only adding additional marks, but we've also added two more really valuable transforms. We've added a window transform, and we have also added a select transform that can help us place things at a specific subset of the data that we're using, which I think is really helpful. All right, moving right along. We still got a map to make. Okay. So I'm going to go back to my slides because this is what I think is like so awesome about like developing skills in the grammar of graphics and using tools like Plot is that you don't have to learn an entirely new set of skills or an entirely new subset of knowledge to be able to quickly extend what you've already learned to create something new or to create a new chart type. And that's why I wanted to show you all an example of creating a map with Observable Plot is because now that you have, after sessions 1, 2, and most of 3 now, the basics of building observable plot charts under your belt, there is a whole world, in this case, literally, of data visualization that is now within your grasp. And everything that you've learned so far, you can apply to creating and customizing maps or other chart types that you haven't even created yet, with some of these like foundational skills and foundational knowledge for plot. So we're going to be creating a map and thinking about how what we create in this map aligns with what we've already learned about plot, because there's really only one like very new thing that we're going to add, which is a projection. And the way that we're going to do this is using the geo mark, which is amazing. So this is a mark, right? Just like plot dot dot or plot dot line or plot dot text, right? This is just a way of representing our data, where the geomark specifically is made to draw geographic features, polygons, lines, points, and other geometries, often as a thematic map. And it works within Plot's projection system. So we're going to see some different projections today, and we can play with different projections, but these slides also link to the Plot Geo documentation where you can find the projections that you can use. So the projection is kind of the one thing in the example we'll be doing that we haven't seen yet, but otherwise it follows the same exact structure. So we're going to start by initializing the plot, and then within that initialized plot, what we're going to do is first provide this projection information. And a projection relates to how do we take information that is actually on a sphere, an imperfect sphere, a sphere that is our world, right? Spatial data is supposed to represent something on an imperfect sphere. And how do we visualize that in 2 dimensions? Because there's a lot of different ways to do that. And I've shown a couple here, but there are many more built-in projections, many more types of projections at large in the world, but there's also many different types of projections that are already named within observable plots projections. But for example, we can see that the way that that information from a sphere is visualized in 2 dimensions is very different based on the projection that you pick. So we're going to see how that changes the visualization that we create. But we're going to call this projection by name. And then after we do that, we are going to say what our marks are, just like we have previously. And then we will give it the information on the plot geo mark. That's what we want to create. And then the spatial data that we're actually creating our visualization from. So this is what we're going to do in our next example. So let's hop right over to it. Okay, so heading back to my notebook, I'm going to scroll down to activity 3. And in activity 3, what we're going to be visualizing is we are going to take a look at meteorites, where they've fallen or been observed around the globe, and a mass if it's been recorded. So these are, for example, this is the data set. It's stored as meteorites. You can see in the name of this data table cell down here. Each of these meteorites is named, which is very cute. They also have a class, so you can learn more about like the class of meteorites, which I have no idea about, but I think that's very cool. There's the mass in grams, whether it has been found or fell, the year that it fell, and then it has this information about latitude and longitude. So the latitude where it's recorded and the longitude where it's recorded. So these are the pieces of information that we're going to use to add our meteorite information to a global map. Now, where are we getting information on this global map from? That I have already imported. So if you scroll down to the bottom, you don't have to, you can just look. So I have already imported this land spatial information, which is global land masses, from an existing observable notebook. So this is immediately available for us just by doing this import, which is so cool. So we have land, right? So we have the land. We're going to give plot a projection so it knows how to take that information from land and show it to us in 2 dimensions. And then on top of that, we're going to add a dot mark, which shows us the location where each of these meteorites fell. So that's our plan here. But we're going to use all of the skills that we already know to start building this. We are going to build this one from scratch. So there's not a built-in, there's not an existing base chart. So to do that, just as a reminder, above activity 4, I'm going to choose in the left-hand margin, I'm going to select a plus sign, and that opens the add cell menu, and I'm just going to choose JavaScript. So I'm going to choose JavaScript, and this opens for me a new blank JavaScript cell. And this is where I'm going to start typing my plot code. So here, I'm going to start by initializing the plot. Plot.plot. And then I have open and close regular parentheses, open and close curly braces. Then I give myself a little bit of room between those two to start adding things. Okay. So now we've initialized the plot, but we haven't added anything to it yet. The first thing I'm going to do is say, I know I'm going to be creating a map using plot geo, and that's going to need a projection. So that's the first thing that I'm going to add. I'm going to say the projection is, and what's really nice here is that now you can see that as soon as you type your open and closed quotes, you can see that the different projections all show up here. So I, for example, am going to choose equal Earth. I can also just type that in, but it's nice to be able to just select them because you're going to want to play with them. It's pretty fun. And then I have a comma. And within this, then after this, I'm going to say what my marks are. So I have marks, single colon, and then I have my open and closed square brackets after marks. And this is where I'm going to add two things. I'm going to add my land masses using plot geo, and then I'm going to add my meteorites using plot dot so that those are each represented as a dot. So here I can do plot.geo. This will never stop feeling like unbelievably awesome. And if I just tell it, use the land data, which again, remember that was already imported, and run this, then congratulations, because you have already created a world map in Observable Plot, which I think is so awesome. But the really cool thing here is that like the things you already know about plot also apply to this mark. For example, I can add options within plot geo. I can have, just remember you have your options within curly braces. I can say, I want the fill color to be a light gray. And now it has this light gray fill color, which is really cool. So you can continue learning what you've learned about syntax and structure and options, even when you learn new chart types, which is pretty cool. Okay, but the final thing that we want to do is add these meteorite locations, and we're going to add those. That's going to still be a mark, but those are going to be dots that show up. So I'm going to split this up a little bit just to give myself some more space. So now I have plot geo on its own line. To add a new mark, I'm going to add a dot mark. So I'll use plot dot. But now instead of pulling data from land, which just is the data for land masses, I'm going to use data from that meteorites data set that I've already attached and loaded in. And then I'm going to tell it where these exist. And those are based on the longitude and latitude. One thing that always gets me hung up is longitudes are X and latitudes are Y. So for X here, I'm going to use the values from the rec long property for the recorded longitudes. And for Y, I'm going to use rec lat for the recorded latitudes. And with just that, now I can see that the locations of these meteorites are now shown on my world map, and we could continue customizing those using the same options that we've been using for plot dot all along. Like that this is now shown on a map doesn't mean that everything you've learned about mark options already don't apply. Like I could do, I want the fill color to be purple, but I want the radius to be based on mass in grams. And then I would probably want to change the range of these dots, right? Those giant ones are really giant. But we could change those within that R scale, right? We could change the domain, we could change the range so that there's a more compressed size range for these dots. But it's pretty cool that so quickly we can take what we've learned so far and apply those to now building a really fast map, which is awesome. So definitely look at the plot geo mark and examples for observable plot, because there's really amazing examples of what you can create, and many of them with really not very many lines of code, which is cool. Okay, so we are gonna now hop into, for the last 5 minutes, a very quick introduction to interactivity. So what we're going to do is we are going to just take a glimpse of one example of an observable input, and then we're going to change one of the charts that we made already to actually be interactive. I promise we could do this in 4 minutes. All right, so I'm going to scroll down to activity 4, and this is only meant to explain how this is actually working. And then we're going to create our own version of this with our line plot with our moving window that we created above. So this example, and we're going to do more of this in session 4, but this example uses observable inputs, which are lightweight interactive user interface elements or widgets that a user can interact with to change a value. So this line creates an input. This happens to be a color input, and its job is to let you pick a different color. And that color is stored in a variable named pick color. So based on what a user selects in this color picker, the value of pick color is actually instantaneously changing. Instantaneous is not true, but it's changing pretty immediately. So here, just to kind of show what this is doing, if I add a line that says pick color here, which shows me the value, then you can see that this is changing as I change my different colors in that color picker. And because that value that a user is selecting is tied to a name of a variable that we can call elsewhere, then we can change something about a chart to be connected to that dynamic variable, that input value. So here, for example, in this chart below, if instead of setting a fill color to like red, so if instead of setting a fill color to like red, or instead of setting it to a single hexadecimal color code like coffee, then instead of setting it to an absolute value, I could say, actually, I want the fill color to be whatever the current value is of pick color. And then now that it's connected to that input value, when a user changes their input value, then you can see that the chart color fill is changing. So I can see that this chart color fill for those dots is also changing. So inputs give you a really nice way to both create and show a little user interface element, a widget, but also quickly connect it to an element of your chart because it gives you that variable storing the current value of that input selection. We're going to do a bunch of examples in the next session on this, but let's go ahead and just give it a shot with something that we already created earlier today. So let's go ahead and scroll back up to our line chart where we calculated the moving averages. And notice here that I had specifically set a value for K, an absolute value of 30. But like we just saw, we can instead connect this to an input value that changes based on a user selection. So the way that we can do that is right above this chart. I'm going to open my add cell menu by pressing that plus in the left margin. And I'm going to start typing in slider. And you can see that an option for a slider input shows up. And I'll change this range from 1 to 100. This is going to be the total range of values. and I'll change the label to pick K. And when I just run that, you can see that now I have a widget that I can interact with that is going to be storing, using the name range by default, the current value of that input. And that means that if I instead want my window size to change based on this selection, then all I have to do is call this dynamic variable storing that value by name. Instead of setting K to an absolute value, I'm going to say set it to the current value of range. And now I can see that my window actually changes based on that slider. So that is just a very quick introduction to how we can start using inputs to quickly make interactive charts. We're going to do more with that. We're going to do more with custom tooltips. We're going to add crosshairs in the next session in 2 days. So thank you so much. I'm going to stop there. So I'll switch back to my slides. Session 4 is on October 26th, and the entire focus of that day is going to be on making your observable plot charts interactive. So thank you so much for joining, everyone, and we will see you at session 4. Bye, everyone.